From the tallest skyscrapers to the fastest cars, engineering design is at the heart of every remarkable creation. And in this video, we're going to explore the crucial process of engineering design. To find out more, watch this video. Hey guys, I'm MJ Sanga, your creative engineer. Now, almost everything that has been built has gone through a process or steps before it reached its final design. For example, cars. Before they were released into the world for consumer use, they went through a long, rigorous design process. Engineers tested different materials, engineers tested the parts, engineers tested the car as an assembly, as well as the design of the car to see its aerodynamics and so on. So much process went into the design of a car before it was released for consumer use. This same process is known as engineering design. To explain further, engineering design is the creative and systematic approach to solving complex problems by applying scientific and mathematical principles. It involves a multi-step process that ensures the successful realization of ideas into tangible products, structures, or systems. The engineering design process typically consists of 6 key steps. Number 1, we define the problem. Number 2, conducting research. Number 3, generating concepts. Number 4, selecting the best solution. Number 5, creating detailed designs. And finally, testing and refining the product. Now, to help explain each step, I'll design a product using SolidWorks to explain how each process goes. Every product that has been released for consumer use has solved a problem that an individual has been going through. For example, cars that are efficient when traveling long distances. Our smartphones help us connect by talking to people from different countries and families who live long distances. And home appliances like an iron make us remove the creases on our clothes to make us look more smarter and better looking. Now, the first step when it comes to engineering design is first defining the problem. This is done by clearly understanding the goals, constraints, and requirements of the project. Engineers work closely with clients, stakeholders, and end users to gather information and establish design criteria. Let's say I'm hired by a client to design a car jack for their company. Client A is a company that deals in producing and selling car accessories, and they would like to start manufacturing their own car jacks and selling it out to consumers. The goal of this project is to produce a car jack that can lift cars with a maximum weight of 2,500 kilograms. They require that most of the parts can be easily produced by CNC machines, so meaning that NC code is needed. It should also be easy to assemble and will not need any electrical or hydraulic parts. After having a long meeting with client A and gathering information on this project, we then move on to the next step, which is conducting research. Once the problem is defined, engineers embark on a research phase. They explore existing solutions, study relevant scientific principles, and gather data to inform their decisions. Research helps engineers understand the possibility and limitations of their project. In this case, I searched the internet, scavenging through journals, videos, and books to understand the basic concepts of how car jacks work so that I can create a design. It also helps me to know what I should focus on the design. From the information I've discovered through my research, I've discovered that there are different types of car jacks, and relating to the requirements that the client has given me, the best car jack to design is a scissor car jack. After gathering information, we then move on to the next step, which is generating concepts. By the way, if you're enjoying this video, please hit the like button and subscribe for more of my upcoming content. Now back to the video. Now, with the knowledge gathered, engineers then move on to the concept generation phase. This is where brainstorming comes in, and engineers are allowed to explore various ideas and potential solutions. They begin by sketching concepts, and using computer-aided design, they create 3D models to visualize their prototypes. Using SolidWorks, I designed each part accordingly. I made sure that every part that would be connected with a screw has the same hole size, and from what I designed, I came up with this. I would then send the work that I've done to the client, seeing if they like it or if they need something to be redesigned, or if they do not like the concept. And if they do not like the concept, I then go back to the drawing board to create a new design, send it to them until there's something that they can agree on. We then reach to the fourth step, which is selecting the best solution. With a range of concepts at hand, engineers evaluate and analyze each one based on technical feasibility, cost effectiveness, and other criteria. The goal is to identify the most promising solution that meets the project's requirements. To help with this decision, they perform computer simulations and models to help analyze each design and see which is best. For performing analysis, I usually use ANSYS Workbench to analyze the structure, test the stress and strain, and so on. We use this to ensure that the force of the car doesn't easily destroy the jack, so testing with different materials is important as well. After a solution has been chosen, we then go to the next step, which is creating detailed designs. When creating detailed designs, engineers dive into the specifics, accounting for factors such as the material, manufacturing process, the structural integrity, and so on. Detailed designs are typically documented using technical drawings and specifications. It is on these technical drawings that give manufacturers things such as the tolerance and how to manufacture most of the parts. In this stage, we create 2D sketches and the NC code and send it to the manufacturer so that they can create prototypes to see how the part looks physically. Next, we have testing and refining. Obviously, when it comes to creating a physical prototype and testing it out in the real world, there's a possibility of there being uncontrolled variables that might not be considered when using ANSYS Workbench. That is why there's a huge difference between 3D modeling a part and manufacturing it and allowing the engineer to handhold the product and test the design physically. This is why we test the design over and over to see if there's any fault that might occur if the end user is using it in a situation. We must know that no design is perfect and there's always room for improvement. That's why we constantly test and refine the design to see how we can make it better over time. So then, after constant testing and redesigning, the client will give it a thumbs up and allow the manufacturer to mass produce the product. It is then packaged and sent out to many stores for consumers to buy and use in any situation needed. And there you have it, engineering design in a nutshell. But remember that engineering design is an iterative process. It doesn't take a day. It can take weeks or months before the final product is actually allowed to be mass produced and sent out for consumer use. Engineers often revisit earlier steps, incorporating feedback and making improvements until they achieve the desired outcome. Engineering design is the bridge that connects imagination and innovation to the world of applications. From everyday gadgets we use to the groundbreaking structures that shape our world, engineers continuously push the boundaries of what's possible through their ingenious designs. I really hope you enjoyed this video. If you want to watch more of my videos, let's say learn about the skills needed to make a robot, you can click the link right here. Or if you want to learn about jet engines, you can watch my video right here. Or if you're interested in AI and want to know how quantum computers work, you can watch my other video right here. I really hope you enjoyed this video. Please hit the like button and subscribe for more of my upcoming content. Let me know what you think about engineering design in the comments. And share this video to let people know about engineering design and how it works. Have a good day, and I hope to see you again in my next upcoming video.